Okay, number 2, we're given a graph of a function of several variables. We're asked to find all relative extrema and saddle points. So the first thing we need to do is find the critical points. So the critical points of a function of several variables, we need to find the first partials. We need to find where both of these are 0 simultaneously, or we need to find where one or the other messes up. So let's take the derivative with respect to x. We hold y as constant. And the derivative with respect to y, holding x constant. Both of these partials exist everywhere, so it's a matter of setting them both equal to 0. So we have a system of 2 equations and 2 unknowns. We can solve the top equation pretty readily for y. Y is negative x cubed. And I can substitute that then in the second equation. So 4 times y cubed, well, that's minus x cubed, plus 4x is 0. And now I want to go solve this for x. I simplify this, I get negative 4x to the 9th plus 4x is 0. I factor out the 4x. Negative x to the 8th plus 1 is 0. And now I split it. I've got either 4x is 0, which means x itself is 0, or I get negative x to the 8th plus 1 is 0. I get x to the 8th equals 1. And I would take the 8th root of both sides. And since I'm solving for an even root, I got to have my plus or minus. So I get x equals 0, x equals plus or minus 1. So what do I do with these numbers? I go back to my substitution equation. So y is negative x cubed. So the one value, x equals 0. So I get x and y both 0 there. When x equals a positive 1, so I get 1 comma negative 1. And when x equals negative 1, negative 1 cubed is negative 1. Take the opposite of that, I'm back to 1. And so these are our critical points: 0, 0, 1, negative 1, negative 1, 1. So what do we do with the critical points? We run them through the second partials test. So we have fx and fy from before. Fx was 4x cubed plus 4y, and fy was 4y cubed plus 4x. So fxx, I take the derivative with respect to x again, I get 12x squared. fxy, I take the derivative with respect to y, I get 4. fyy, take the derivative with respect to y, I get 12y squared. fyx, take the derivative with respect to x, I get 4. And so we have a quick check that we did something right because these mixed partials match up. So what I need to do is analyze my d. fxx fyy minus fxy fyx. 12x squared times 12y squared is 144. X squared y squared minus 4 times 4 is 16. So this is my d. So now I look at each of the critical points. 0, 0. D at 0, 0 is going to be negative 16. And what's important about negative 16? It's less than 0. And if D is less than 0, we have a saddle point. Let's look at 1, negative 1. d of 1, negative 1. 1 in for x, negative 1 in for y. I get 144 minus 16. That's going to be bigger than 0. So if d is bigger than 0, I need to check fxx. So I take fxx at 1, negative 1. And I get 12 times 1 squared. And this is 12. And that's bigger than 0. So with d bigger than 0 and fxx bigger than 0, that tells me that we have a relative min at that point. Let's look at negative 1, 1. Well, d of negative 1, 1 is going to give me the same, 144 minus 16. What's important about that? It's bigger than 0. So I go look at fxx. That's also bigger than 0, which means we have another relative min. So we have a saddle point at 0, 0, and relative minimums at 1, negative 1, and negative 1, 1. And so that'll do it then for checkpoint quiz 9.